This video will work through problem 11.7 from Gapenski's Healthcare Finance, 6th edition. Problem 11.7 deals with Regal Health Plans. They've issued a 12% annual coupon bond with $1,000 par value a few years ago. The bond now has 10 years remaining to maturity and sells for $1,100 today. The bond has a call provision that allows Regal to call the bond in 4 years at a call price of $10.60. Part A asks, what's the bond's yield to maturity? Okay, so what do we know? So we know that the bond, it doesn't matter when it was issued. We know that it has 10 years left. So if we're going to work with yield to maturity, it has 10 years left to maturity. We know that the coupon rate is 12%, and we know that the par is 1,000. So we know that the annual payments are going to be 1,000 times 0.12 or 120. And we know that the price today, or the PV, is 1,100. So if we draw out what this looks like, we have 0, 1, 2, 3, 10, where we are going to pay $1,100 for the bond. We're going to get 120, 120, 120, 120, blah, 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 out to here, 120, plus we get our par payment at the end for a total of 1,120. So we're buying for $1,100. We're buying a stream of 10 $120 payments each year, plus at year 10 we'll get $1,000 payment of our par value for a total of 1,120 in year 10. And so we want to know, what is the yield to maturity? So for our calculator, we need to do n equals 10. PV equals 1,100 minus 1,100. Payment equals 120. FV equals 1,000. And then we're going to calculate I, or the yield to maturity. So here we go. Clear that. So we got N is 10. PV is 1,100 negative. Payment is 120. Future value is 1,000. Compute interest rate, and we get 10.35-ish. For students in my class, this 10.35 is fine. Rounding to the nearest hundredths is fine. If you're not in my class, your professor may have a different preference, so you'll have to work with her or him about that. So that's the answer to part A. And part B is, what's the yield to call? All right, well, so yield to call is a little bit different, right? So the problem says that they could, that Regal could potentially call their bonds in 4 years. So now we're working with a theoretical 4-year time frame. The PV is still the going price of 1,100, right? And I'm making it negative because it's out cash flow. We're buying the bond for 1,100, and you have to put in a negative sign when you do when you use the financial calculator. If you're doing this in Excel, you don't have to do it that way. The payment is still 120. However, the future value, right, is going to be different. So let's do our little timeline: 0, 1, 2, 3, 4, 1, 2, 3, 4. We're still paying 1,100. Don't make it negative. Being redundant here. I started putting negative, then I put parentheses. So you use one or the other. So I'm getting rid of the negative. So it's still going to be 120, 120, 120, 120. But the FV, right, the call premium is $60. So the call price is going to be $10.60. So if they call, investors should be evaluating this as, this is how you would evaluate the possible outcome if Regal were to call. If you were to buy the bond, you're either going to get 10.35 if you can hold through the end of 10 years, or if they call in 4 years, you'd get this stream of payments, 4 $120 payments plus a $1,060 payment, your par value plus a $60 call premium for a total of $1180 in year 4. So the FV in this case is 1060. And now we want to know what is I, or the yield to maturity. So go back, clear our TVM. N is 4. PV is 1100. I'm making it negative to feed the calculator. 120 payment. And then 1060 is our FV, compute I per Y, and we get 10.13-ish. So the yield to maturity, if they call at the year 4, they'd pay that extra call premium, but investors would the yield to call would be 10.13 versus 10.35 if they hold or if Regal does not call.